everyone, in this video we're looking at applications of the normal distribution using Microsoft Excel. So just a quick review of the normal distribution. If you haven't already watched the video describing the normal distribution, I will link that in the description. But the normal distribution is this sort of bell curve shaped probability distribution, and because this is for continuous variables, our probabilities come from the area underneath the curve on a given range of values. Now, in order to compute this area, mathematically speaking, what we're doing is an integral, which requires calculus. But in practice, we're going to find these areas either using a lookup table called a z-score table for the standard normal curve, which the standard normal curve is the normal curve where the mean is 0 and the standard deviation is 1. Or we can use various types of technology to find specific areas, including Excel, but also, certain graphing calculators, online calculators. There's a lot of different technologies out there that can compute these areas. So I want to start with this first example. We're looking at some data on the sleep amounts of adults. And based on a random sample, we are assuming that sleep follows a normal distribution that has a mean of 6.2 hours and a standard deviation of 1.9 hours. So that's giving us a description of kind of the general population of how much people sleep each night. And I have 3 different questions related to this in this example. The first question is, what is the probability that a randomly selected adult slept less than 8 hours last night? So visually speaking, what we're looking at here is this normal distribution curve with a mean of 6.2 hours. So I'm showing a graph here. The peak of this bell curve is at 6.2. And then the standard deviation 1.9 is controlling how spread out the peak is. This would be a little more spread out than the standard normal distribution. So the probability that a randomly selected adult slept less than 8 hours would be the area that has 8 on the right and goes all the way to the left. So this is shaded in pink here. 8 is a little higher than the mean, so we see that cutoff point on the right side of the distribution, and we're looking for this area. I definitely recommend that you just sketch out a little picture like this. It doesn't have to be super precise, but mostly just to get a sense of, is the area we're looking at, is it going to be more than 50%, less than 50%, close to 1, close to 0? Get a sense of what kind of answer we're expecting just visually, and that can help make sure that you're getting the right answer when you do the calculation. So based on this picture, because we're looking at area to the left of a number higher than the mean, this should be more than 50% because we have more than half of the area under the curve. To do these calculations using Excel, we're going to use a function called NORM.DIST. The DIST stands for distribution, so the normal distribution. The NORM.DIST function is going to give us area to the left. So this is an important clarification that we can specify a particular x value and the mean and standard deviation of our distribution, but it's always going to give to the left. Now, in this case, that's what we want for this problem, but if we want area to the right or a different type of area, we need to do some modifications to the output of this function. So in this case, here I have the same picture in Excel. I just pasted it in here for a visual. I'm putting in the mean and the standard deviation. The mean was 6.2 hours. The standard deviation was 1.9 hours. These represent sleep amounts. And so the area to the left of 8 would be equals norm.dist. So the normal distribution function, I'm doing a parentheses here. And then I'm going to put in the first input Excel calls x. That would be the number that we're interested in this case, the 8 hours, comma, put in my mean. Now I could just type 6.2 here, but if I have the mean somewhere else, I can also click on the cell. Either one will work, comma, the standard deviation. Again, I could type in 1.9, or I'm just going to click on the 1.9 in cell B2 here, comma, And then the last input to this function is the cumulative flag. If you used the binomial distribution function in Excel, you remember the same flag from that function. The cumulative piece, in this case, for working with the normal distribution, we always want this to be true because I want the cumulative area or the cumulative probability from 8 all the way down, to the left. If you do false here, what it will actually give you is the height of this probability density curve, the height of the normal distribution curve at 8. That doesn't really represent anything in terms of probability. It's not really useful to us in this class. You could use it if you were trying to graph the normal distribution curve or something like that. But for these types of problems, you're always going to be using true in that last input. Also, true is equivalent to any number besides 0, so you could just put 1 here or something like that, and it would do the same thing. So this gives me the result 0.828274. Again, this represents this area to the left of 8 underneath our normal distribution curve with mean 6.2 and standard deviation 1.9. So this says that about 83% of the time, or 83% of people in the population, sleep less than 8 hours. Coming back to our example, the second question here was, what's the probability that a randomly selected adult slept between 7 and 9 hours, which is the recommended amount of sleep? So I'm going to come back to Excel. I have this in a tab for B. So same mean and standard deviation. We're still talking about the same distribution, but I've inserted another picture here. This is looking at the area that's bounded in between 7 and 9 on that horizontal axis, and then the area bounded underneath the curve. We can see, visually speaking, that this is a smaller area, so I'm expecting a number that comes out less than 0.8, and that area represents either the proportion of all people or the probability of getting a randomly selected person who sleeps between 7 and 9 hours. Now, the trick here is that NORM.DIST function can only give us area to the left. It's not set up to do area in between two values, but we can still use that function to find the area in this picture. What we're going to do is find the area to the left of, say, the smaller of the two numbers, so area to the left of 7, and then separately we will find the area to the left of 9. We can do both of those with this function. And if we find both of those two areas, you can see that they overlap. The area to the left of 9 contains the area to the left of 7. So we'll just take the difference between those two, and that will give us the area that we want, that's sort of in between those two values. Area left of 7, this would look like norm.dist or equals norm.dist parentheses. I'm going to use 7 as my x, and then I'm going to use my mean and my standard deviation, and either true or 1 for that cumulative input. So this shows the area left of 7 is about 0.66. And then for the area left of 9, I'm doing equals norm.dist parentheses 9, comma, and then I do my mean and my standard deviation. Again, you can just type in those numbers if you want, if you don't already have them in separate cells. And here I get 0.929717. All right, so I'm going to take the difference between those two in a new cell. I'll do equals, click on the larger of the two, minus the smaller of the two. And this gives me that difference in area, or 0.266575. That is the area in between, bounded by the curve in between 7 and 9. And this would represent the probability of finding someone randomly selected who sleeps between 7 and 9 hours, about 27%. One last example or calculation from this first example. Here we're saying the 5% of people who slept the least slept more than how many hours? So this is a little bit different. It's a different type of question. Visually speaking, we're thinking about the same distribution, same mean, same standard deviation, but here we're seeing that the area bounded by some unknown value. So the value along the x-axis here in my picture is unknown, but what we know is that the area here is 0.05. So this is imagining looking at that lowest 5%. You can also imagine we could look at like the highest 5% or 5% around the mean or something like that. But here we have the lowest 5%, and we're trying to figure out what x value, or in this case, what sleep value would correspond to that area. For this, we're going to use a different normal function. So in Excel, this is NORM.INV. The INV stands for inverse. And in this function, rather than putting in an x value, we put in the area to the left. So just like the NORM.DIST gives us an area to the left out, this is giving us the area to the left as an input. And then our mean and standard deviation, similar to the NORM.DIST. There's no cumulative flag in this function because the NORM.INVERSE function is just naturally cumulative. And this is going to spit out what we would normally put in as an input for x, so that, in this case, the sleep value. So here I'm going to do equals NORM.INV. This first input, Excel calls it a probability, but this is the area to the left that we're looking at. In this case, this is 0.05, that 5%. We want the area to the left of our unknown value to be 5%. And then I'm going to put in my mean and my standard deviation as those next two inputs. Close my parentheses, and this tells me 3.074778. So again, this is not an area, this is an x value. This is, in this case, a sleep value. So just over 3 hours. So this is saying that 5% of people sleep just over 3 hours or less. Your final answer might look something like 5% of people sleep less than 3.07 hours. I have one more example here. We have a different distribution. The average price of a new car in 2024 is estimated to be $48,397. So that's our mean. If car prices are normally distributed and the standard deviation is about $28,800, then we're going to answer a couple of these questions. Just a comment, I did actually look up the average price of a new car in 2024, and it is $48,397, and I estimated the standard deviation. It's hard to find that information online, but car prices are probably not exactly normally distributed. They probably have some kind of skew to them. But just for the sake of this example, we're going to assume that they are approximately normally distributed. So if we consider randomly selecting a car, the price of that car then would follow this normal probability distribution with the given mean and standard deviation. The first question asked here is, what is the probability that a randomly selected new car costs more than $90,000? So I'm switching over to Excel. Again, I have a graph pasted in here. I would recommend drawing just a simple normal curve. You don't need to have the axes perfectly correct here, but put in the center 48,397, and 90,000, the number that we're looking at in this problem, is definitely higher than the mean. So you should have some kind of mark off to the right-hand side of the bell curve. And in this case, we're looking at the probability of getting a car more than $90,000. So we're shading in to the right of that 90,000 mark. You'll notice that in this graph on the vertical axis is this really, really tiny number. Because the standard deviation here is so big, we have a wide spread of prices. The height of the curve is really, really tiny, so I had to zoom in a lot to get this graphed on the graphing program. But again, if you're sketching by hand, just a very basic bell-shaped curve with a specific center, and then roughly put that 90,000 mark above the mean. There's a bit of a trick here. If I do equals norm.dist and put in my 90,000 and then the mean of 48,397 and the standard deviation of 28800, And then we are again using the cumulative version, so I put in true. If I calculate this, this number is not going to give me what I want because this is giving me the area to the left. So I can tell as soon as I calculate this 0.925, this is more than 90%. That doesn't match the little tail area that I have in my picture. This is too big. And that's again because it's finding the area to the left, not the area to the right. But we can correct for this. So this is to the left. The area to the right that we actually want here is just the total area minus the area to the left. And the total area under the bell curve is always 1 because that's 100% probability. So I just do equals 1 minus, and then do my area to the left value. I'm doing this as a separate calculation here to get 0.074292. This would be our answer here. The probability of getting a car more than $90,000 is about 7% or 0.074. You can do this as a single calculation if you want. If you just put 1 minus in front of the normal distribution function, that will do that area to the right automatically. But sometimes it's nice just to break it down so that you know exactly what each of these numbers mean. And the last question from this example was the most expensive 5% of cars cost more than what amount? So our picture here is going to be pretty much the same, but rather than setting a set dollar amount cutoff of $90,000, I don't know what my dollar amount is here. So my horizontal axis number is unknown. But I'm looking at this area to the right and saying, I want that area to the right to be 5% or 0.05. This is similar to the last question on the previous example. I need to be using the inverse function. So I'm going to use NORM.INV. And that first input, which Excel calls probability, this is the area to the left. Now, we are not given the area to the left in this question. We're given the area to the right. So we need to actually figure out before we calculate this what the area to the left is. Now, area to the left is just 1 minus the area to the right. I could type in 1 minus 0.05 here. 1 minus 0.05 is also 0.95. So I could calculate that out just directly and put 0.95. Doesn't really matter how you do the calculation, but we need to get that area to the left in order for this to calculate the right value. If I put in 0.05 here, that's going to give me the cutoff for the lowest 5%, not the highest 5%. So I'm going to do 1 minus 0.05, or you could do that 0.95. Area to the left would be essentially 95%. And then I'm putting in my mean and my standard deviation as those last inputs, and I will calculate this out. This gives me a number that is higher than the mean, which is what I expect. And this output would be a dollar amount. If you wanted to, you could format this cell with dollar signs. This is $95,768.78. So 5% of cars would be at this price or higher. So all of our normal distribution functions in Excel or our normal distribution calculations will be based on either the NORM.INV function or the NORM.DIST function, depending upon whether we're trying to calculate an area or whether we have an area and we're trying to calculate the value associated with it. That is it for this video. Thank you for watching.